Yeah, so in terms of kind of where it all began and why we as a company are here, as you can probably imagine, disabling hearing loss is a very serious condition that affects almost 500 million people all over the world. And it can have a significant impact on not just the individual, but also health systems, societies, just as people sort of start living longer. And for those living with hearing loss, it not only means losing your ability to recognize sound, but it can also lead to social withdrawal, isolation, reduced self-confidence, reduced self-esteem, which can have a lot of sort of additional health problems, but also have an impact on those they love, like their family and their loved ones. So there's a real big sort of impact when it comes to hearing loss. And the way Cochlear sort of fits into this is we create implantable hearing solutions that sort of aim to give the gift of hearing back to those that either have lost their hearing or never had hearing in the first place. And those solutions we can talk about in a little bit more detail later. But the main ones that you've probably heard about are our cochlear implant or our bone conduction implant. And again, these products are really there to give the gift of hearing back to those that don't have hearing anymore. And it's quite an interesting topic because it's really hard for us to understand what it's like to not hear for those of us who have been born with hearing, because it's not something you can switch off, if you will. So I guess a little bit of today is kind of highlighting this problem, and also talking about what you as an engineer could do to help kind of rectify this sort of problem statement here. And if we can jump to the next slide, and I can talk a little bit about sort of our mission at Cochlear. And that is to help people. Our mission drives everything we do here at Cochlear. We help people hear and be heard. We've been here for roughly 40 years, creating reliable products that continue to keep people connected to the world and to each other through, again, the gift of hearing. And our technology, again, connects people to life's full possibilities, and also to the people that matter most to them. And to date, we've helped hundreds of thousands of people of all ages, all over the world, change their lives, their emotions, their experiences, and their opportunities through the experiences that sort of hearing brings. And we're here to sort of help even more and sort of innovate and bring to market a range of technologies that will deliver a lifetime of hearing outcomes to those in need. If we can jump into the next slide, Cochlear does have a very large global footprint. We are a global leader in what we do, and we were the first one to make a commercially available multi-channel cochlear implant. So that's that first there. We also have 6 manufacturing facilities worldwide, and we invest heavily in research and development, almost $2 billion plus. So R&D, or research and development, is something that is integral to us, given sort of our mindset here to really innovate and bring to market technologies that fit to current lifestyles. Additionally, we have roughly 4,000 employees globally dedicated to improving the lives of people. And Cochlear to date has provided more than 600,000 implantable devices. We are in over 180 countries where these devices are available, have roughly 100 plus research collaborations worldwide, and also 40 years with a history of treating hearing loss over the world. If we can move to the next slide, as I mentioned, we do have a global footprint, and we're a well-known example of how an Australian innovation can sort of successfully transition into global advanced manufacturing success story. For those of you that don't know, the Cochlear implant was pioneered by an Australian e-surgeon, Professor Graham Clark, in Melbourne. So it's an Australian, again, innovation. And we're actually also headquartered on the campus of Macquarie University in Sydney. So headquartered in Australia, which is quite rare for most organizations. And we, at the same time, have regional headquarters all over the world in the Asia Pacific, in Europe, in Latin and South America, as well as in North America. And if you can see all the dots there, we have regional operations, again, all over the world, and also have manufacturing, I guess, offices all over the world as well. Yeah, and like I mentioned, we have direct operations in roughly 35 countries, so those blue dots, but we sell devices and our devices are present in more than 180 countries. So really a shining example of, how, a very Australian sort of innovation can translate globally. What's quite unique about, I guess, the fact that we're sort of headquartered in Australia is that uniquely to Cochlear, you do feel very much at the center of all things, given that this is where our global operations are really conducted, whether that comes to R&D or outside. So that's a really unique part about sort of being headquartered here in Australia. If we can move to the next slide. Like I mentioned, we do invest a lot in research and development, and that means that we do invest a lot in our engineers. And we have our legacy science and engineering summer student program that's been running for, I think, 13 plus years here in Australia. That program is an internship program for students studying a STEM-based degree, and is applicable for almost every engineering discipline, as well as most science disciplines, and now also open to a few sort of internship itself is an 8 to 12 week program that runs during the summer, roughly around end of November to mid-February. And the internship placement occurs in our research and development department, but also our supply chain and operational excellence department, and could even be within our IT department. But for the majority of you, given that you'll probably have more of a mechatronics background or similar, likely to be placed in sort of the R&D or research and development department here. What's quite unique about Cochlear's summer student program, one, is the fact that it's a legacy program. So you will be working on some really great projects that directly contribute to Cochlear's product development, and will give you a real insight into working as a professional engineer. You also will have a community of not only sort of interns that are within your respective cohort, but other sort of individuals kind of in the same circumstances as you, so have done an internship with Cochlear before, probably a graduate engineer now, who you can leverage of, and you sort of have that community of grads and interns within organization. Just as exciting. And like I mentioned, you get to work on some real projects that, again, directly contribute to Cochlear's product development. So likely to be highly confidential, probably not something we can talk to in a lot of detail today, but we can give you a bit of life-changing projects, and also challenging for you in terms of technical ability, because we're really there to have you learn what it's like to be an engineer in a professional sort of industry circumstances, and that too in the medical industry, which is quite rare. But enough about that. In terms of eligibility, I've listed there kind of what we require for students to be eligible for that respective internship program, and that is to have full ongoing working rights, studying a STEM-based degree, being in your penultimate year, which essentially means that you'll need to finish your final subjects in calendar year 2022. And you'll also need to have a credit average. Applications for Cochlear's Science and Engineering Summer Student Program will close at the end of the week, so on the 30th of April. If you haven't applied already, please do apply as soon as you can, so as long as you meet sort of that eligibility criteria. And if you have any questions around this, feel free to either post it on the chat or we can discuss it sort of later on in the Q&A session. But happy to answer any questions you may have. Great. Hopefully I didn't rush through that too much. I'll hand it over to you, Max, to go over sort of how hearing works in our product portfolio from now.
Great. Thanks, Jen. Okay. So I'm Max Cornwell. I'm a DSP engineer, as previously discussed, I think. And so I'm in R&D, basically, at Cochlear. Okay, so let's start off with how normal hearing works. So the first step is that the sound passes through the ear canal. So the pinner itself actually imparts a bit of kind of information onto those sounds to help kind of with your brain kind of work out where sounds are coming from, not just in the left and right, but also up and down. That comes through, it strikes the eardrum, which causes vibrations in the middle ear bones, so the ossicles. Now these little tiny little bones actually act as something of a impedance matching network between the air and the fluid in the cochlea. So once the cochlear itself is vibrated, this sets up a kind of standing wave within the cochlea, within the fluid within the cochlea, which causes tiny hair cells to vibrate, which then in turn stimulates the cochlear nerve, which sends an electrical signal to your brain, which interprets that and turns that into the kind of sound that we experience. Now, an interesting thing about the way that the cochlear is structured that is, as it turns out, quite helpful for us is that the way that standing wave gets set up for different frequencies means that different regions along the cochlea respond to different frequencies. So it's tonotopic. So we get low frequencies at one end and high frequencies at the other. Now, this is something that we actually take advantage of in our technology. Now, there's a lot of different steps here where something can go wrong. You can have conductive hearing loss. There's a problem with the ear canal. You can have, again, conductive hearing loss if there's a problem with the bones in the middle ear. And you can also have sensory neural hearing loss if there's a problem such as with the hair cells, which is actually one of the more common forms of hearing loss. And of course, you can have it to different degrees of severity. So we develop a range of products, including cochlear implants, bone conduction implants, active osseointegrated implants, which address those different types of hearing loss. The one thing we don't make is a kind of traditional hearing aid that just kind of plays the sound louder. In the Sydney office, we mainly work on kind of our core product, which is the kind of nucleus series of implants, and that's the kind of traditional cochlear implant rather than a bone conduction implant, which is actually developed in our Sweden office. So one of our kind of promises always is that these implantable solutions will kind of give our recipients like a lifetime of hearing. So all our implants are, I think, well, all our cochlear implants are, I think, rated to last for 75 years. So how do cochlear implants actually work? Well, cochlear implants are designed to kind of mimic some of the function of the healthy inner ear. So they replace the damaged sensory hair cells that are inside the cochlea. And so they kind of bypass a lot of those mechanical steps and provide a kind of electrical hearing rather than the traditional, well, the natural acoustic hearing. So there's kind of two main parts to a cochlear implant system. There's the external sound processor. So this includes the microphones that capture all the sounds and turn those sounds into electrical signals that are then sent onto the implant. These electrical signals tell the implant kind of which electrodes to stimulate and how much current to stimulate on each of those electrodes. Audio processing for cochlear implants is somewhat different to most audio processing in that we kind of actually don't have sound as our output. It's this pattern of electrical stimulations rather than converting it back into a sound. Like you might do in a hearing aid. So that comes with some challenges in terms of development. You can't just like listen to one of our sound processors. You kind of have to simulate it or kind of use an acoustic output, which doesn't necessarily capture the whole signal chain. So next up, we have the implant itself. So that's surgically implanted under the main body is surgically implanted under the skin. And then there is an electrode that is inserted into the cochlea. So spirals around with electrodes arranged, taking advantage of that tonotopic structure of the cochlea. So some electrodes will correspond to some frequencies and others to higher frequencies, and in a kind of sensible increasing order. So the way that the sound processor actually communicates with the implant, it's across an RF kind of inductive link. So that's what you can see in kind of this number 2 here. Alignment is achieved using 2 magnets. Basically, that helps keep the mat coil in place and in the right place. So Cochlear provides a kind of a range of implants and electrodes to address what any recipient's particular type of hearing loss, the cochlear anatomy, and also to cover a range of surgical preferences in terms of how the exact electrode shape might be. So our most recently released cochlear implant is the Nucleus Profile Plus, or CI600 series. So this is designed to for routine kind of 1.5 and 3 Tesla MRI imaging without the need to remove the internal magnet. So generally it's quite similar to the previous generation, but it has this different magnet that can actually rotate within the body. And so this allows the sound processor to kind of be used with much stronger magnetic fields, because that magnet can align to the magnetic field, so you don't have such a risk of the magnet perhaps flipping or something. We have a kind of 3 electrodes that are our kind of main electrodes. There's the slim modiolar electrode, the slim straight electrode, and the contour advanced electrode. So the slim modiolar electrode is Cochlear's kind of most advanced perimodiolar electrode. It's designed to make it really easy to insert the electrodes into the cochlea, which is quite a small space, so it's no easy task for surgeons. So it's got the thinnest full length perimodiolar electrode. which gets as close as possible to the modiolus. Now, the modiolus is the kind of center of the cochlear spiral. So by hugging the modiolus, we actually decrease the distance between the electrode and the cochlear nerve, which runs through the center of the cochlea. This means that we get less current spread, so we get more specific activation of the nerves. And it also means that we get a lower impedance. So that gives recipients better battery life, as well as kind of a more flexibility in terms of the stimulation rates that they might have, as well as some other benefits. We still do offer a choice though. So some surgeons might prefer a contour advance or the slim straight electrode, which basically just based on surgical preference, depending on their workflows. The contour advance is kind of just the previous generation of what the slim modiolar is, though it does have a slightly different workflow. The slim straight electrode might also be used in cases where there's kind of an abnormal cochlear structure. So you don't necessarily have that nice kind of that seashell shape that the cochlea normally has. So it can be more useful to have something a bit straighter, so that the surgeon can do a bit more manipulation. Now, in terms of the sound processors, these three sound processors on screen are kind of our current generation. So the Nucleus 7 on the left is our kind of current behind the ear sound processor. It's the smallest and lightest sound processor on the cochlear implant sound processor on the market. I think that's still accurate. The sound processor, the Nucleus 7, not only was it smaller than the previous generation, but it also started to include a lot of wireless streaming capabilities. So you can have direct connect streaming to your phone, whether it's an Apple or an Android device. Now, the behind the ear profile of the Nucleus 7 is kind of the traditional profile for sound processors, and it's similar to a hearing aid. But we also have a range of kind of off the ear sound processors. So those are those Kanso sound processors you can see on the screen. So a recipient might choose one or the other for a number of reasons. They might like having something behind the, they might not like having something kind of hanging on their ear, might get in the way of glasses, or it might just be uncomfortable. Or they might prefer the Nucleus 7 because they feel it provides better retention, or it's in some way better suits their personal preferences. So these sound processors don't fasten onto the ear or anything. They basically just hang off the using the magnet inside the cochlear implant. Though there are kind of retention accessories so that if it falls off, it doesn't just kind of disappear. You can have hair clips and that kind of thing. So the Kanso sound processor is kind of our first generation of this button processor kind of thing. It didn't actually have all the functionality of the Nucleus 7 sound processor, but it kind of was actually quite popular. In some ways, it provided a better hearing experience than we almost expected, because there are some engineering challenges in terms of the acoustics, with the microphones being kind of further around the back of the head. But it ended up being a really successful technology. So the Kanso 2 is a similar idea, but it now has, instead of a button interface, it has a tap interface, which is a bit easier to kind of find. You don't have to locate that little button. It also provides some more sound processing tools, such as our kind of forward focus, which is a very kind of intensely forward focused kind of beamforming thing, so you can only really hear what's coming from the front rather than besides, which helps remove noise that in a noisy room or something like that. It also adds in that wireless streaming functionality that the Nucleus 7 sound processor has. So between Kanso 2 and the Nucleus 7, we've kind of got a technology a sound processor platform that has all of those kind of streaming capabilities and app integrations that we that people really find useful, and it's kind of a part of modern life. So other than these three sound processors, we do actually sell a number of older versions of kind of the Nucleus line. These are mainly to markets where they're kind of sold as like a budget option, or in some markets where the regulatory process is quite slow, so we don't necessarily have regulatory approval for the newest sound processors. We also sell a number of accessories. So aside from direct streaming to a phone, you might need to use kind of traditional Bluetooth streaming, or you might want to stream from a TV, or there's also a microphone and another type of remote if you don't want to use the app, that kind of thing. And of course, we have the app itself. So this app, its kind of primary purpose is to provide kind of indication of battery life, control over the different settings that are available on the device. It also has some other features, such as the Find My Processor feature. So if a recipient has lost their sound processor, which is apparently reasonably easy to do, they're quite small and they actually have a tendency to jump off onto metal surfaces, given that they have a big magnet in them. And so that provides kind of an easy way to find it. It'll just kind of point you in the right direction and pulse more as you get closer. A kind of hot or cold kind of way of finding your sound processor, which might be lost. So that's the kind of additional functionality that we get from having something like a smart app. A piece of functionality that the smart app gives us is a relatively new feature called Remote Check. So this Remote Check feature actually allows recipients to do a lot of hearing tests that they'd normally have to go into an appointment with an audiologist to do. Now, as you can imagine, this feature has been a really big hit in the past year. It's become much more difficult to go out and have face-to-face time with clinicians. It's been undesirable with the risk of, spreading the coronavirus. So this has been a really, this came out kind of at a very opportune time for us, and it's, so it's been very popular. Now, this feature required collaboration across different teams. So it's not just a kind of add the functionality in the smart app kind of situation, because a lot of the tests need to do things like measure impedances, and they play sounds across the sound processor. There's actually a lot of firmware work and signal processing work required to implement a feature like this. And there's also obviously the kind of IT backend that kind of supports the kind of data communication, sending the results back to an audiologist, sending the results of any questionnaires that are included. So that's kind of an example of how a feature that isn't necessarily a piece of hardware actually requires still a lot of collaboration across different parts of the business, and particularly different parts of R&D. So speaking of this kind of collaboration, what's the process of engineering at Cochlear? What's the innovation process? It looks something like this. So this is a summary of what we call the product innovation process at Cochlear. It's not quite as it appears internally in documentation in terms of the formal steps, but it gives you a sense of the different steps that are required. Now, as an engineer in R&D, I spend basically all of my time in that dotted box, in particular in the design, prototype, and test, and design, verify, and verification and validation box. But coming up with a concept and doesn't kind of come from a vacuum. We need to get a lot of insight from customers about what they need, identify problems people are having out in the field, kind of come up with solutions to those problems, and develop strategies around solving problems and identifying kind of market opportunities. But of course, these solutions and strategies need to actually align with Cochlear's mission, our values, our commercial strategy. Once we have the actual kind of product itself, kind of after this green box, we then need to the kind of job's not done. There's still a lot to go in terms of regulatory submission. So regulation is a really important part of Cochlear's business. We are a medical device company. Typically, an active implantable medical device will attract the most kind of strenuous regulatory inspection, from a regulator. So we need to prove that the device that we've created is not just effective and kind of provides some clinical benefit over what's been released before. Excuse me. But we also need to demonstrate, of course, that the device is safe. This is of particular concern for implants, but also is an important part for the external parts, because there is that interface always into what is actually being stimulated inside people's heads. So there's a lot of regulatory, I guess you could say, regulatory burden in terms of what we do. We always have to think about regulation. There's actually a fair bit of documentation that needs to be done for all the different steps, and our whole development process has to comply with kind of quality standards, and that's all inspected or rather audited quite regularly by regulators. But there's also, yes, the regulatory submission step, which is always an exciting point in a project's life. We also have to build the commercial product. Just because we've got a prototype that seems to work well on our benches in R&D doesn't necessarily mean we have a product that's ready to ship. There's a whole lot of manufacturing engineering required to develop the processes to develop different components. Of course, that kind of process development for manufacturing doesn't actually just happen right at the end. Everything that they have a role to play right from the get-go, but they kind of gradually take on more responsibility, particularly once we've completed the kind of the design, verification, validation kind of milestones. Once we've actually launched the product, which requires a whole lot of clinical education to get clinicians on board, marketing, obviously, to get recipients excited for a new sound processor or aware of the new functionality that a new implant might contain. There's a whole process of sustaining engineering and monitoring. So sustaining engineering basically means keeping the product in production. Components that were used in the original design might become obsolete, so replacements might need to be found. We also might need to respond to any complaints that might come from the field. And there's also a process of kind of monitoring device returns and seeing if there's any trends in how devices that are returned are breaking, basically. And this could raise what's called the corrective and preventative action, which is where we kind of say we can see that there's a problem, and then there's a formal process around making sure that we solve that, or solve those problems. And of course, the monitoring step isn't just the end of the development process. It's also the input into the development of the next product. So be that the next implant, sound processor, the monitoring what's happening with our current product portfolio always informs what we might need to change, or what new things we can do with our next kind of set of products. So in more detail, this kind of set of 4 steps. Step 1, of course, is propose concepts. So this really is where we take those inputs from marketing and the kind of clinical side of things, and actually start coming up with concepts for what the next product could actually involve. It might also contain some prototyping, not necessarily of a full product, but rather of kind of aspects of a product. So we might have a look at how the device might look. We might be prototyping kind of new sound processing technologies, but potentially using the previous sound processor as the platform for prototyping. Then we select a concept. This is where we kind of get all those ideas and say, well, this is what we're actually going to look like, what it's actually going to look like. By this point, we've normally started to have some more substantial prototyping. And then next up, we have the design, prototype, and test. And this is where we actually start building proper prototypes, really start refining the process, the design from all parts of it, like examining the performance, seeing what's the usability. This is where the manufacturing process really, developing the manufacturing process, so that process engineering that then feeds into actually building the product, starts to kick in. And it's also involves a lot of the kind of characterization of components and that preliminary testing of against requirements we might have developed, and of course risk analysis and early customer input. So we don't necessarily wait for the device to be fully complete before getting some customer input, particularly if there are new features. We might have kind of acute testing to evaluate particular aspects of a new device. And then the next part is actually checking that the device does what we say, what we want it to do, and that it kind of performs the way we want it. So that's the verification and validation step. Now there is a part of the business that is kind of responsible for verification and validation. So there are specific verification and validation engineers, but it's not something that is purely done by them. There's obviously a lot of work done by the kind of more R&D engineers to actually help prepare and execute verification and validation of a new technology or product, whether that's a sound processor or an implant, or at the other end of the spectrum, just a new version of the app. Excuse me. So then from there, it feeds into what I discussed on the previous slide, the kind of regulatory process, which is an important part. And of course, at all of these steps, we don't just necessarily charge onwards regardless of what's come out of the previous step. There's always a meeting in which the stakeholders say, are we actually ready to move on to this next stage? And so sometimes products will hit the point where we say, we think this is ready, but then in review, actually we'll say, no, we need a bit more work on XYZ components of the device. or the product. So there's a whole group of people within Cochlear who work on bringing out a new product or innovating. There's obviously R&D, SC and OE. I always forget what that actually stands for. It's a relatively new acronym, but basically that's they're the ones that do the manufacturing of the device. There's a clinical team, so that entails basically building the evidence that that the devices are actually working, so running clinical trials, that kind of thing. There's obviously marketing, so marketing are important not just for selling the product once we finished it, but also for providing those inputs into the kind of start and also throughout the process. There's always a bit of input from marketing. There's obviously quality and regulatory. They're the people that make sure we're still allowed to, we can still be allowed to continue making our technologies, our products, and services provides kind of grab bag of other things that we need to keep the product working. And of course, the main role for engineers here is really in R&D and SE and OE. But of course, engineers are not necessarily locked into that aspect. I know that there are plenty of engineers in services, quality and reg, even some in clinical, and of course, there's engineers in marketing who provide that kind of engineering expertise to the kind of marketing team. And then, of course, around that, there's the typical business functions that are kind of a universal part of keeping a business actually running. So there's finance and legal, IT, and P&C. So that's kind of the whole. That's kind of everyone that works on building a product, and that covers pretty much everyone who works for Cochlear, I'd say. So what kind of opportunities are there for engineering, or particularly mechatronic engineering at Cochlear? Mechatronics fits in a lot of places because mechatronic engineers kind of sit in that zone where there's a bit of mechanical expertise, a bit of kind of electrical, a bit of computer science type study. Mechatronic engineers really fit in all over the place. So research, quality, process engineering, obviously design. Design could mean electrical design. It could mean mechanical design, depending on where you're the best fit. One place that mechatronic engineers are particularly useful is kind of test systems. Test systems often kind of, whereas the rest of the company will all work on these different little components, test systems product is a test system, but that means that they kind of act as their own little development group. So having that like cross-functional skill, being able to do a bit of the kind of programming, but also having awareness of how the mechanical engineering process will work, and obviously electrical too. Like that's a really good. It's a really good place to be if you want a bit of everything. Oh yeah, and there's engineering not just in Sydney, but also in our Belgium and Sweden offices, and I think there's still a small R&D office in America as well as a lot of like the kind of regulatory affairs and quality kind of things all over the world. We also have some production in Kuala Lumpur, in Malaysia, and I think we are also opening up some kind of manufacturing capability in China. So a case study about me. So I started off doing a mechatronics/biomedical engineering degree in 2013. I had visions of working on mind-controlled prostheses, kind of mind-controlled wheelchairs, a lot of kind of mind-controlled X. And with time, I actually became a bit more interested in kind of the interface between the brain and the nervous system and whatever a particular bionic prosthesis might actually be doing, than the actual kind of control of the hardware itself. So that kind of led me to actually switching degrees to electrical engineering. Then in I think 2017, when looking for internships, of course, one of the first options to come to mind as someone who was interested in biomedical engineering, and particularly that kind of nerve kind of bionics interface, Cochlear was a really appealing option. It was also appealing in part because I had a personal connection to Cochlear. My grandfather has a cochlear implant, so I've kind of been able to see firsthand the really huge impact our technology can have on people's lives. And then I was lucky enough to be selected as a summer intern. So I joined up with the kind of firmware and signal processing team. I was given a project that actually can't still talk about the details of because it's still in development, but I actually did a lot of the early implementation of this kind of new algorithm to be used in our signal processing. And I was given a project that kind of straddled a bit of the firmware side of things, a bit of the DSP side of things. And it was a really great opportunity to do something that was really kind of real engineering. I wasn't just mucking around or being a kind of technician or anything like that. I was really kind of integrated right into the team. Into R&D. And that's one of the great things about the summer program at Cochlear, is that you really actually do get to have an impact on our products. It's not just pretend engineering. You're really doing work on our products in R&D. Another part of that summer internship that I really enjoyed, though, was that we actually had kind of weekly talks from different parts of the business. So both throughout R&D, but also the broader business as well, kind of saying, this is what we do, this is what's going on in Cochlear at the moment, kind of really building that understanding of the whole of engineering, and even not just the engineering that goes on at Cochlear. So from then on, I was lucky enough to then be selected as a graduate engineer. So that the graduate program at Cochlear involves kind of 12 months of rotations. So you basically get to pick where you want to go. It doesn't have to all be in R&D or the kind of SCNOE, the manufacturing side of things. You can really, it's a chance to kind of spread out and see not just a lot of different parts of engineering, but also different parts of how a business works. So as well as doing rotations in the electrical team, the software team, the systems engineering team, I also did a rotation in the kind of clinical marketing team in what's called APAC, which is the Asia Pacific kind of head office. So working on getting an understanding of the kind of how we can better interact with our with the clinicians. So clinicians are really one of our customers. It's not just the recipients that we see as our customers, it's also the clinicians. And so I got to have a really good opportunity there to meet doctors. I actually was able to kind of sit in on a training workshop which was something I wouldn't have seen if I'd just gone straight into a pure engineering role. So it was a really good opportunity to spread far and wide. Then, of course, at the end of my year as a graduate, it came time to actually kind of end up in a final position. So one of the good things about the graduate program at Cochlear, which is not necessarily a universal fact, is that universal process amongst all businesses is that once you're in the grad program, you've got a guaranteed kind of job at the end of that. So you don't need to worry about reapplying for jobs all over the place. Once you're in as a graduate, you're in a permanent position, not just a year contract or anything. So finally, I ended up in digital signal processing, which I was really happy to end up in. You of course get a lot of say in where you actually want to go. So yeah, it's been a really interesting journey to get to this point. I really enjoy working as a digital signal processing engineer. Really get an insight into how how we actually kind of take sound and turn it into that kind of pattern of simulation, and really feel like I'm making a big contribution to our recipients' kind of quality of life by giving them better hearing performance, basically. So that's kind of my story. I might just finish up with what I love about working for Cochlear. So Cochlear is a global company. It's a very collaborative company. Collaboration is kind of a really important part of the kind of culture of the company. As an intern, even I found that all the engineers around me who had might have had many years of experience, everyone's always very happy to help out, to kind of talk about ideas, talk about problems you might be having. It's a really supportive workspace. Everyone's always ready to help and communicate kind of openly. We're kind of anti-silo. There's always collaboration between different R&D functions, between R&D and outside of R&D, and also with our colleagues kind of overseas. So as a engineer, as a DSP engineer in Sydney, I actually have a lot of communication with the team in Belgium who work on some of our fitting software. And as an intern, even I actually worked quite closely with one of the engineers in the R&D office in Denver in America. So there's a really great team. It's a global team, so there's a lot of different experiences to learn from all the engineers here. And it's very open culture. It's also there's obviously a big focus on innovative engineering. We are the market leader and we want to stay that way. And the way to do that is to really have an organizational focus on engineering. So engineering is very well supported within the business, but also there's a great culture of trying things out, seeing what works, and we're always striving to improve our technologies. And finally, one of the great things about working for Cochlear is that you really have a direct sense that you're helping people. We're not just making commodities or consumer electronics. We're actually working on something that's really life-changing. So it's great being able to come into work every day and knowing that in doing your work, not only are you intellectually stimulated by the interesting problems that you're faced with, but also solving those problems actually has a real measurable and substantial impact on people's lives, and a really positive impact on people's lives. So I think that's kind of all from me. I think we'll probably move over to the questions now. I might just bring that back up.
Yeah, thanks, Max. That was awesome. Like I mentioned before, if you do have any questions to those in the call still, feel free to post it in the chat and I can answer them or Max can answer them. Alternatively, you are more than welcome to unmute and perhaps ask questions yourself, or yeah, whatever works for you. I'm mindful that we're very close to time, but yeah, I'll be here, and so will perhaps Steve and Max to make sure that we answer some of the questions you have. They can be any questions related to recruitment or Cochlear in general, or engineering-y technical questions. Again, very happy to answer anything here. I'll give you perhaps a couple of minutes to type some up or unmute and ask. I've also posted an advert link for Cochlear's summer student program in the chat, so feel free to have a look at that program. Again, the main sort of eligibility criteria there is for you to be in your penultimate year, and that is an eligibility criteria. I do see a question in the chat. So how many places are available for this summer program? It's a really good question. So historically, we usually have between 25 to 30 positions available for our summer student program. So that's roughly how many we'll be taking in for this year as well. So I see another question in terms of what was the recruitment process for the Cochlear internship like, and do you have any tips in terms of experience they're looking for, etc.? I can speak to what our current recruitment process is. So currently, which changes year by year, but we plan sort of a 3-stage application process for Cochlear Summer Student Program. The first stage is an initial application. So kind of if you go through that link that I sent through, submitting your resume, answering a couple of questions so that we can understand sort of your interests at Cochlear, as well as disciplines that you're interested in. And the second stage would be a virtual sort of group activity assessment, followed by a psychometric assessment, which is quite standard for most sort of recruitment processes when it comes to internships and grad programs. And finally, the final stage would be sort of a technical one-on-one interview with a manager at Cochlear, and very likely to be a senior sort of engineer at Cochlear, followed by offers. So that's roughly the timeline. In terms of tips of what we're looking for, look, I did say technical. In terms of technical experience, we aren't necessarily, going to expect you to have a lot of past industry experience, just given that you are going to be in your penultimate year and also likely to be studying an undergraduate degree, and a pretty frantic one at that, given it is engineering. But we do expect you to have some basic sort of understanding of the technical components when it comes to your respective degrees, whether that's electrical, mechatronics, or if you have dual degrees. So yeah, basic knowledge within your respective disciplines is what we do expect. But apart from that, we're really looking at those softer skills, which I'm sure you get hammered on when it comes to other sort of industrial talks. But it's really a key to any professional role when it comes to understanding your awareness of your own collaboration styles, your communication styles, how you plan and align your work, so you're prioritizing your tasks. I think those are really key to being successful in any position. So those are the tips, would be really hone in on your collaboration skill sets, your communication skill sets when it comes to communicating to diverse people, not just perhaps those that are from a STEM background. And also, you're going to be placed in very professional work environments, which means that you're going to be faced with a lot of challenges when it comes to projects. So making sure planning and aligning and ensuring sort of your accountability are also some of those softer skills for you to work on and ensure success in any role. I'll forward this question on to you, Max. How did you get feedback on some of the work that you do? Are there internal review processes, or do you work with senior engineers? And also, are there programs available at Cochlear to upskill?
Yeah, so how do I get feedback on my work? At Cochlear, in the firmware and DSP team, we use kind of the agile or Scrum kind of development methodology. So all our work is kind of broken down into relatively small tasks. Most of these tasks will be coding. Some of them will be testing or documentation, that kind of thing. So at the end of any task, whatever it is, there's always a review process. So that's an opportunity for a fellow engineer in the team, basically to have a look at what you've done and provide any kind of feedback, kind of code review, that kind of thing. It's also a good opportunity to see, what else other people in the team are actually doing is by reviewing their work, building that knowledge within the team. So that's kind of for the small level things. We also do, if you're working on kind of a big feature or something like that, there will also be design reviews and that kind of thing. So that'll typically be kind of cross-functional. You'll kind of present, this is the design that we've come up with. This is why we've done what we've done, and provide evidence and that kind of thing. And then you'll typically get a bit of feedback, a bit of asking for some more information in different parts, and hopefully some kind of tick of approval from the kind of DA